Hi, my name is Gal Koenigsfield and this is TranstextNet, transducing text for recognizing unseen visual relationships. This research is in collaboration with Rana Leoniv at the Technion, Israel's Institute of Technology. We studied the task of scene graph generation where given an image we could decompose this task into two subtasks. The first, detecting the objects, and the second, recognizing the relationships between pairs of objects. State-of-the-art scene graph generation systems consist of three layers. The first, an object detector, used to detect objects and extract regional features from the image. The second, a context layer, used to contextualize regional features such that they are represented in a context of either subject or object. And last, a relationship recognition layer that infers the correct relationship between pairs of objects. These systems have several shortcomings due to both data and architecture. On the data side, some relationships are strongly dominated by others. In this example, the relationship holding dominates the relationships gripping and dribbling. There are also squared number of possible relationships with respect to the number of objects. However, most objects do not interact at all. As you see in this example, there are many objects in the image that do not interact. For example, the headband does not interact with the right hand, and the ball does not interact with the man in the background. We propose TranstextNet to overcome these shortcomings. TranstextNet bridges current scene graph generation architectures with free text to achieve better recognition of relationships and enable recognition of unseen relationships. In order to extract meaningful information from the text, we need to distill it. To do so, we use a scene graph parser. This parser takes a sentence as an input and outputs all the possible subject-relationship-object triplets. We propose using the information distilled from the text implicitly rather than using the counting statistics of the text. To do so, we propose an object relationship mapping layer. This layer utilizes the information distilled from the text alongside fusion mechanisms that enable transductions of relationships absent from the training data. This slide summarizes the object relationship mapping layer. This layer accepts the detected object classes and pooled features of the union bounding boxes. It utilizes the object classes to extract relationship candidates from the text, and by utilizing the distributed word representation, fuses these candidates with the visual features. We test two fusion mechanisms, attention and feature-wise linear transformations. Here we show TranstextNet as a modification of a general scene graph generation architecture, where we add object relationship mapping layers that utilize the free text to enable better scene graph generation. The ORM layers that are now glowing are plugged at two intersections of the architecture. The first, the output of the context layer, and the second, the output of the relationship recognition layer. The results compare state-of-the-art scene graph generation systems at the top with TranstextNet. These results illustrate two benefits of our method. The first, better recognition of less frequent relationships. And the second, better foreground and background detections. Here we see results of a new task we defined, unseen relationship recognition. On the top, no unseen relationships are recognized by the state-of-the-art scene graph generation systems, while at the bottom, TranstextNet is able to recognize two unseen relationships, part on and beneath. This enables better semantic representations of images by using free text. Here are the quantitative results for scene graph generation. We see TranstextNet improves all scene graph generation systems and achieves new state-of-the-art results on both recall at K and mean recall at K. Here we see results of unseen relationship recognition on the left and zero-shot scene graph generation on the right, where again TranstextNet improves state-of-the-art by a large margin. Thanks for joining our presentation. We hope you enjoyed our paper.